neXt Curve.
Welcome to another episode of neXt Curve's Rethink podcast, where tech industry leaders discuss the trends and technologies that are shaping our digital future. And I'm Leonard Lee, Managing Director of neXt Curve. And today, I'm happy to have a very special guest, Roy Chua, founder and principal analyst with AvidThink. Thanks for joining me, Roy.
You're very welcome, Leonard. Glad to be here.
Do take a moment to introduce yourself and AvidThink.
Absolutely. So AvidThink is a small boutique analyst firm. We actually spun out of SDX Central, which I co-founded back in 2012. And as some of your readers may know, or your listeners may know, SDX Central was one early company that covered things like SDN, NFV, and so on. And that was back in 2012. And we had both a media operation and a research operation. And I ran the research side of things. 2018, we took the research group and we spun it out. And sometimes people ask, so just like light reading, heavy reading? I'm like, yeah, just like light reading, heavy reading. It's we're the heavy reading portion of it. And people are like, oh, I get it now. I'm like, yeah, okay. Yeah, so we are that. And what we focus on is infrastructure technology. And we, as all analyst firms do, we publish a bunch of reports. We talk and we have opinions. And so far, it's been great. We work with some of the leading providers in the industry, Fortune 50s, as well as some of the very innovative startups. And what we are focused on primarily is just technology infrastructure. So not the RF and not so much the optics, right? But anything above that, all the way up to the application infrastructure itself. So even cool things like cloud and Kubernetes, we do cover. So just that section.
You know what? I have to tell you, I'm a bit of a fan.
Likewise, it's mutual.
Oh, thank you. And this is really exciting. And you know what, Roy, we're going to be talking about network and compute service placement. And the reason why I invited you to the show is because, you wrote this really, really cool piece. It's for Amdocs, but it's on the topic of network function placement. And I actually read the whole thing, enjoyed it very much, thought it was very well researched, and I just had this compulsion. I just had this voice in my head say, hey, look, you got to get Roy on, because we just published a research paper through Intel on the topic of 5G autonomous edge. And so I think there's a lot of intersect between what you've written on the topic of network function placement and what we've written in terms of what's happening with 5G and the edge.
Agreed.
And particularly with AI. And so I thought this is just going to be a great opportunity for us to jam and see what kind of new insights we can generate through an organic discussion.
No, absolutely. No, and I read your piece too. So,
wow!
Okay, right?
Thank you.
The mutual admiration society going on here, but yeah, no, that was nicely done. Yes.
No. Seriously. Your paper is great, and I highly encourage our audience to check it out. Okay, we'll provide the link in the abstract so you can go directly to it, and then we'll also have a link to the neXt Curve paper on 5G autonomous edge. But no, seriously, I brought you on because I really, really thought it was a great paper, and so we're going to be talking about a couple of things here. Actually, four things. Number one, we're going to be talking about what the big deal is with end-to-end network slicing. We hear that a lot.
Yep.
And what does it mean for mobile networks, right? And then the other thing that we're going to talk about is this concept of network function placement that you so eloquently address in your paper. But what we're going to do is we're going to tie it to its role as a critical element in mobile edge computing, right? And then what we'll do is we'll talk about what are some of those key capabilities from a network function and compute placement perspective that are going to be critical for some of these, I would call them more of the advanced or aspirational 5G use cases, right? URL LLC, and then maybe some varieties of enhanced mobile broadband. And then finally, what we'll do is we'll just talk about what are some of those valuable applications that we see at being able to take advantage of dynamic network function edge compute placement. Does that sound like a plan?
Sounds like a good plan to me.
Okay, great. So why don't we start off with the end-to-end network slicing? I mean, what's all the excitement about, Roy?
Yeah, so the concept around 5G that I think we've been promised and are promising right from the carriers is the ability to take your network, in effect, your physical network end to end, and then create this virtual slice, right? And that slice has attributes of isolation. So it's got some concept around isolation. But more importantly, and we talk about that a lot, is the quality of service, right? It gives you some SLAs that you really care about, right? It gives you some amount of maybe jitter control. It may give you some latency guarantees. It may give you some capacity of bandwidth, guaranteed bandwidth, right, from end to end. And the hope is that by having this end-to-end slice, that you can improve the performance of your applications, or you can transfer your data with more reliability, with more guarantees, right, for a whole bunch of use cases. So that is the promise, right? And now, I mean, on 4G networks, it's not that you can't prioritize traffic. There's QCI levels and different ways of prioritizing traffic. And we know that first responder workloads can get, higher priority than maybe streaming media. But we don't use a lot of it today. It's not exposed to the end user in particular. You don't have the flexibility of the size. So I think, in terms of the scale of number of potential slices, in terms of the guarantees and the SLAs and the sophistication of that, in terms of the dynamism, provisioning it, on demand, right? None of that exists today on the 4G network primarily, and that's what 5G promises, and that's coming. But we're definitely not there yet, right? I mean, if you look at the carriers worldwide, the vast majority of them are just in the process of rolling it out. Right. And for most cases, you need a 5G core, so you have to go from non-standalone to standalone to get there. Right. I know of only sort of one major MNO today that is actually providing some level or some aspect of slicing, and that's China Mobile. In July, they actually explained what they were doing. But again, China has 90 plus million 5G subscribers now, at least that's what they publish, right? And so China Mobile actually has a model. They have these nice little models that say, hey, you can buy this, or you can buy this, and you can buy this. That's the first commercial instance I've seen for a large MNO to offer effectively, differentiated services based around 5G network slicing. Right?
We're like synchronized. I just shared that on LinkedIn today.
Yeah, I just saw that. Yeah, the original article is on the website in Mandarin. So actually, it was in our newsletter in July. So in July, I found that in Mandarin, and then I shared the link, and I said, "Look, it's in Chinese, but it's but here it is." Right?
Oh, sure. I can't read Mandarin. I know Chinese characters, but I'm just really bad at Japanese, Korean. Yes, but. No.
Yeah, but Google Translate will fix that. So I sent it out, and I'm sure people use Google Translate. And so, yeah.
Yeah. And, I think that's a great point that you're making, that we're not there yet. There's this huge transformation that needs to happen that everyone talks about. And that with the introduction of Release 16 of the 3GPP 5G specifications and standards, now we see a lot of the technologies following suit with the new specifications that were, I think, when were they frozen?
Early July. It was supposed to be end of June. It was just slightly late, right?
Yeah, it was 3 months off.
Because it was pushed out originally, and then they were a couple of days late from that date. But again, COVID-19 happened, so I don't think anyone could have seen that coming. Right.
But the good news is that we have Release 16, and
yes, we do.
As you mentioned, standalone 5G cores are now ready to go.
Process. Yeah, in process. Yes, absolutely.
So one of the important things that comes with standalone is the end-to-end network slicing, right?
Yes.
Or at least that capability. But I think you're making a really important point here, in that these new services that everyone talks about, you still need to be at achieve a certain level of maturity.
Yes.
In your network and your operations in order to realize these new services, which kind of, it's actually, quite frankly, shocking that China Mobile is able to go to market as quickly as it has. But, you have this diagram in your paper, which I thought was really, really cool. It's called the 4 stages of NFV. Yep. And you have these 4 phases. You want to kind of walk our audience through that really quick?
Yep, sure, absolutely. I think visually always makes things easier for me, at least, right? So there's these stages of NFV, because fundamentally, what is NFV, right? NFV is the liberation of these network functions, right, from proprietary hardware, and then you virtualize them, you disaggregate them, and then you scale them and place them across your network and make them run. And these are the workhorses. The network functions, or the NFs, are the workhorses of any carrier network, right? Those are the things that do the work. Of course, you have to control and orchestrate them, but these things actually take packets and do something with them, right? So if you look at NFV and the journey, it starts with very straightforward. It's just virtualizing it, taking your physical network function, the PNS, right, and then breaking it up, virtualizing it. And obviously, as you virtualize it, you have to figure out how to make it run a little better because now it's virtualized. It's not running on the bare metal hardware. It's running on commodity hardware. So you got to do some things around that. Step one is virtualization. And then sort of step two in that journey is what I call cloudification. It's not a word. But everyone's made it up and everyone's okay with it. So it's just called cloudification and containerization, which is a word. And so the second stage is taking those VNFs and making them into microservices. It's actually harder, right? The first step was physical to virtual, and the enterprises already knew how to do that. VMware and all the other virtualization companies had figured out how to do that. But this is harder. Containerization and cloudification requires a re-architecture of the actual application itself, but it's necessary to get to the scale that we need, right? And so this is a process that a lot of companies are at right now, right? They're trying to containerize and cloudify these little microservice architectures and do a cloud native type deployment using all these different collaborating services. And that is in the process of happening. So that's the second stage of NFV, which is sort of where we're kind of at. Right. And the third stage is to actually look at the edge and the multi-cloud. The realization is that, okay, you virtualize it, you containerize it, but it's still running in some telco cloud or telco core somewhere. But to realize now that as we go with 5G especially, that you're going to have to push some of these things out to the edge, right? To get the performance of some of these promises, like ultra reliable, low latency communication, URLLC, you need to push the workers, right? The UPF, the user plane functions, the things that actually do stuff to packets, probably out to the edge, because otherwise you're not going to get your sub 10, sub 5, and maybe eventually one of these days sub 1 latencies, right? And so the realization is the edge is important. And likewise, also the realization that the telco core in the telco cloud is not your entire world. There are these things on your side called hyperscalers, right? And cloud providers who could be your friends, maybe, right? If you shake their hands the right way, right? Maybe, right? Or not, right? Yeah. But regardless, they have resources that are available potentially to use, and they want you to use their resources if you're a telco, right? And so the key here is to realize that now you have a much wider swath of resources available to you that you can place your pieces of your application, your NFV, net virtualization applications around. And so that's stage 3. Stage 3 is recognizing as an edge in the multi-cloud. And then as you build all these things out and realize the complexity is getting more and more, eventually you realize that, wait a minute, humans are not sufficient, and you're going to have to use a lot of automation and most likely AI and ML. I don't see, avoiding machine learning and AI to assist with that, because the rate of change is a lot, and the scale is immense. And so the last stage in our journey of 4 stages is basically getting to autonomous operational autonomy. And so starting with virtualization, you go from virtualization to cloudification, containerization, then realizing there's an edge in the multi-cloud, and then finally there's autonomous autonomy, right? So those are the 4 stages. The vast majority of the telcos are between stage 2, stage 3, in between right now. Right. But that's the journey that we see. And
as you were explaining this diagram to our audience, it just dawned on me that when we think about reliability, ultra low latency or low latency is one thing, reliability is another.
That's correct.
And we have this tendency to lump, because it's called URLLC, which is ultra low, ultra reliable, low latency connectivity. You kind of squish those two things together.
It's separate,
right? And there are actually low latency applications that don't require.
That is correct.
Industrial.
That's correct. That's correct. If you're doing collaboration, for instance, or some amount of real-time collaboration, you can actually lose packets. It's okay, right?
Right. Or even, like non-critical voice communications.
That's correct.
Voice communications, low latency applications.
That's correct. Yeah, that's correct. In fact, I make the point that we are, I was going to write an article, maybe I still will. You see the triangle, right? You always see that 5G triangle, right? You got EMBB, URLC, and MMTC, right? Around that. And I think that's the wrong way to think. That's the telco way of thinking, which is you got to have this or this or this. And the reality is no. The reality is it's a multi-axis space, which is latency, right? You got latency, you got jitter, you got performance, which is capacity, right? And the reality is you should be able to pick any point you want on that space and say, hey, I want that, right? There's a cost to getting there, but you should be thinking like a cloud provider that says, I shouldn't be restricted to this triangle. I should be able to pick whatever I want, right? What attributes I want that makes sense for my application.
Right.
And yeah, again.
And that's what it ends up being at the end of the day when you look at these new services, or if you, as you're thinking about innovating, at least at the network level, these new services, that's what you really need to think about.
Yeah, exactly.
It's going to be a combination of all these things.
That's correct.
But here, and this is the one of the things I always tell people when I'm explaining 5G. It's a lot of these things are things that a carrier has to worry about. Maybe that's the audience we're talking to, but that's, actually it's going to be half of the audience. We also need to explain this stuff to end users. I think that's probably even more important because they're hearing so much stuff about 5G, so much hype, but then at the end of the day, what we realize is this is stuff that carriers really should get excited about, and some of them are, but the end market's looking at the stuff going, wait a minute, I thought I was supposed to get 25 gigabits per second because that's what someone told me, and there are articles that talk about that speed being publicized to the consumer market. And then they go and they get their 5G phone and they go, wait a minute, how come I'm only getting 250 or 300
megabits per second? Exactly. Yes.
Right. Yeah.
No, there is a lot of hype. And I think it's fundamentally what we need to do, I think, as an industry is explain what is possible, when it is possible, and for what applications is it relevant, right? I think that's the key message we all want to get across. Because otherwise, we do all of us a disservice, right?
Yeah. Yeah. And, I like your explanation of this fourth phase, which is autonomy. But I think we also need to think in terms of how you can apply automation throughout this life cycle.
Yeah, absolutely. Yeah.
We were automating things in, stage one.
Correct.
But there's this maturity curve that you're also riding on the automation side where these ML and AI capabilities that are now being introduced into functions such as orchestration, management, planning, et cetera, that do exactly what you were saying earlier. Is those things help us? Well, actually, the way I look at it, it helps us optimize. It's really automation that helps us scale.
That's correct.
Getting that closed loop, which we'll talk about later, because you mentioned that in your paper, and we mentioned that. It's an important part of our paper as well. Those are important concepts to keep in the back of your mind. Riding the maturity curve, right?
It is. No, and that's very important. You bring up a good point, which is autonomy and automation are separate concepts, right? Automation is something that you probably want to have from day one, right? It's to be able to operate at scale and, programmatically and all that. And autonomy is the ability to operate on its own, right?
Right.
And you need automation, otherwise autonomy doesn't work, right? So how is it going to program and interact with it?
Exactly.
It's an important point. Yes.
Right. So everyone talks about zero touch, right?
Yeah.
Zero touch is about you can let the thing go, but you can automate basically by imparting at least some degree of human intelligence to the system, but it's just not dynamic. Which leads us to the next topic that we should talk about, which is the network function placement and how it's critical for mobile edge computing. And just so that the audience knows where my head's at in terms of where our work kind of intersects is really that stage 3, the edge and multi-cloud.
Correct.
You know what? We can probably go on forever on this topic. You hit on so many great points. Multi-cloud itself branches off into totally different, really important discussion, right? Whether especially when we start to think about how these networks are hosted in public, neutral, and private modalities, right?
Absolutely.
But we don't have time to talk about that. We'll focus on this other stuff that's in your paper that I think is just really cool. So you describe it as dynamic network function.
Correct.
Right. Yes. So what I want you to do is share with our audience, what is dynamic?
What we view as dynamic is the ability to, there's sort of two aspects of dynamism, right? One's the ability to be able to ask for these kinds of network slices on demand, right? To basically, as a business, I say, I want a network slice for this purpose, and the system should be able to give it to me, right? So that's that. As opposed to, hey, can I order it for next month? And then you just give me one slice and I'll use it for the next 6 months, right? So I think that's one aspect of that. The second aspect of that is the realization is that the network and resources available to you are not going to be static across the world, right? So if you look at, if from a telco standpoint, we look at what's happening there, things can happen. In the paper, we use an example, unfortunately, of a disaster, right? So pick, as I say, pick your least favorite disaster, right? And then imagine that cell towers have gone down, fibers got cut, right? So now, as a network function placement capability, you have to look and say, okay, the network and resources have changed, right? How do I react to that while maintaining the SLAs, right?
Right.
So the key is always, I have a set of SLAs that I've promised as a telco or as a system, and I have to maintain those somehow. Mm-hmm. And I have a set of resources that's available to me that's changing.
Right.
And how do I ensure those SLAs using the resources available to me that's changing? And how do I adapt to that? And how do I do that by reaching the goal of the minimal cost or whatever, reliability, things, so you have goals and constraints, and you have to be able to adapt to that. So that's the dynamic network function placement, which is the decision that I make. I have to reevaluate on a constant basis because the underlying things is changing. It's not just the input that's changing, which is people are asking me for new things all the time or pulling out old stuff. Mm-hmm. It's also the concept that the underlying resources are changing, right? Mm-hmm. All of a sudden, AWS opens up a new cloud next to me, and guess what? The compute resources there are half the price, right? Hey, right. Let's move everything over, right? So, so I think that's the nature of this dynamic network function placement function, the operation, if you will.
And I'm going to put up your diagram really quick here. This is a really cool diagram. It's called 3 Phases to Dynamic NF Placement, and you have these 3 stages, like you mentioned. You have the static placement. Yep. And then you have adaptive placement, right? That's really the next phase. And, it kind of sounds like SON in a way on steroids, but for the telco network and pushing all that stuff literally out to the RAN where you're interfacing with the radio, the radio head interface to the UE, or the user equipment.
I mean, fundamentally, the concept is you start with, let me just talk about 3 phases first, right? So we have context, right? So on the diagram, you have stage 1, which is static placement, just fixed placement. Let's just start with looking at the resources, making sure that you can actually place them in the right places. And sometimes there's weird things, like maybe your BNF requires acceleration, right? So you got to say, I need to find some place with a smart link, otherwise I can't get the SLA that I need, right? So just looking at those things. The other element in just static placement is there are PNFs that still exist, right? The physical network functions, you haven't thrown away. I mean, you paid a lot of money, millions of dollars for those things. They're sitting in your network, you're going to use them. And so just being able to coordinate across all the resources and putting it there, and checking that the SLAs are actually met, right? And the OSS and ESS are working. That is a lot of effort. That's just stage 1, right? That's just stage 1. The second stage is adaptive, which is now you're going to say, hey, come give me some dynamic requirements and I'll do that, right? I'll be able to do that. And, let's shut this site down. Let's chaos monkey my entire telco cloud and see if I can still meet my SLAs, right? Mm-hmm. This is the adaptive placement, the ability to see what's going on, adapt in real time, right? This is adaptive, which is stage 2. And this is where telemetry, back to your view of, getting information, right? Trying to make it autonomous, right? First, get the feeds. Make sure you have the KPS telemetry. And then you use that and machine learning, to get to stage 3, which is that, holy grail, autonomous placement, right? The autonomous edge, if you will, right? In your terminology, right? You want to be able to use AI.
Not my terminology.
Oh, well, yeah. Well,
I don't want to own that one, man.
In your paper, right?
I don't even want to own cloud. I don't want to own anything. I just observe.
Right. But as in your paper itself, right? It's the ability to then have that thing operate on its own, right? So that's the 3 phases that we see as the journey to get there. And it's a multi-year journey. I mean, it's a complex process.
I think some of the really important concepts are what you're saying with the telemetry, being able to develop contextual awareness through some analytics, or just having visibility to what's happening on the network, right? With the adaptive piece. And that's what's going to enable you to make any kind of adjustments, whether it's manual or it's automated. So going back to what we're talking about, automated. And then once you have that, you can start to develop a closed loop. When you get to the autonomous placement, you're really looking at a learning system, the one that can actually make decisions. I think that's the key point. It can make decisions and adapt on its own, where maybe adaptive placement at that level of maturity, you're not quite there yet, right?
No, it's not quite there. It's simple rules, simple logic. It's not self-optimizing, not by any stretch of the imagination, right?
Right.
But eventually.
And that's the other important point. Having the ability to optimize, basically being able to analyze the performance and then push that back down into the system and say, hey, look, we learned something, or I learned something.
Right.
And we need to adapt. Think about when we start getting into the ML, AI realm, you can do all this predictive stuff. So we hear a lot about intent-based networks.
That's right.
And all that. So I mean, this is a really great construct. But now here's the thing that is the real trip. Now you have, when we start talking about edge computing, you layer now the compute stuff on top of it, right? So now you have, I'll steal a buzzword from GSMA, an intelligent network. That's aware of itself. Now you put compute functions on top of it. It's also, to your point, needs to be resource aware as well.
Correct.
Are there CPUs, GPUs, NPUs, DSP, or other types of hardware available locally? Because this is all about placement.
Absolutely.
Placement's about where, right? Location.
And location, what's available, functions like, EPA, HPA, you can see inside the resource and say, hey, I have this workload. Do you have a match for me resource-wise, right? Can you place it in the right place, right? That's right. I mean, let's just imagine a compute function that requires an NPU or a GPU to execute on inference, right? A neural network. Correct. Exactly.
And it's not available. You only have a CPU.
Yeah, and you can, in some cases, you can make the workload, or you can find an equivalent function that will run on CPU, but you have to use more CPUs, right? And then the system has to decide, can you still meet the SLAs, right?
There you go.
Can I meet my cost constraints, right? And then that's the decision, right? That's why it's a complex process. And I think, over the next 3 to 5 years, it's going to be interesting to watch this whole thing evolve. I think there's going to be a lot of innovation in this space.
Well, they have a concept of federated AI, right? Being able to be federated, not only learning, but inference as well. So you can scale out. And that's one of the things we talk about in our paper. You scale out, and then you can realize parallel processing that's critical for AI inferencing. But again, do I have the resources locally to fulfill the SLA commitments or the application, fulfill the needs of the application locally, right?
Right. Correct. There's plenty to look forward to, plenty of work to do, right?
Yeah. So can you see why I really dug on your paper? It's just really, really cool stuff.
Well, thank you.
Yeah.
Well, we think it's cool, right? There's probably people looking at this like, what are you talking? Like, why?
Yeah, exactly. They're going, what the hell is all this stuff?
I know. But it is interesting. And it's important because, to realize the promise of 5G, right? Really, right? You actually have to figure these things out. There's no choice.
Oh, yeah. And for a lot of the companies that I work with who are trying to innovate, quote unquote, innovate on top of 5G, you have to understand these principles. If you're just going off of what you've read in a, Newsweek or whatever, probably a bad choice of a publication for reading up on 5G.
Not for 5G. Not for 5G.
Yeah, you're just not really going to get that far. You have to definitely go under the weeds and get to the scary parts, which is hardware.
Well, in the end, you have to run on hardware, right? And so you're like, let's abstract all these things away, and then you realize with placement, you actually have to expose what's available in the hardware to the software, so it knows how to place these things, right? There's no way around it. Right?
Yeah. So if placement wasn't about sensing or understanding the availability of resources in a distributed environment, then you just have cloud computing. That's it.
Right. Right. And even with cloud computing, we have to realize, look at Amazon and all the different types, right? So machine types, right? You got to pick your different machine types. Do you want medium? Do you want large? Do you want something with an FPGA? Do you want ARM? Do you want Intel, right? What size CPU do you want? How much memory do you want? So when we look at cloud, it's not one cloud, right? There's many little different clouds sitting in that one cloud.
Right. You're bringing up another really important point, which is the increasing heterogeneity of computing data center. That really needs to be pushed out, or it needs to be pushed out. But the question is, how do you scale that?
How do you scale? How do you manage? And the edge, the realization at the edge is that you probably will need some specialized hardware, right, to make it more efficient, right? So you can't necessarily always use general purpose CPUs. And so now you have, a lot of variety. And how do you manage the variety, right? That becomes interesting.
Yeah, it's the next level of what you write about, and actually that's what we fundamentally address in our paper. Big questions, or at least if you go down to the next level of what we wrote about, I mean that's what that whole paper is about.
It is, and we've done some work for some other different clients around the management of these edge locations, understanding that there's diversity, right? Another important topic, and another lot to talk about. Yes,
another podcast.
Another podcast for another time. Yes.
I had another. You inspired another important thought, and I forgot what it is. Maybe I'll follow up later or make a comment on later on. But let's move on to our last point as a wrap up here. And so, what are some of your thoughts on the valuable applications of dynamic NF and edge compute placement?
So I think some of the most obvious ones that we do see are things that are sort of mission critical, right? So mission critical. So we use in the paper a situation where you have medical services that have to, there's ambulance traveling across. You can replace the ambulance with a fire truck, right? That doesn't matter. So I think that's some aspect of that. But I think beyond that, you also look at things like, cloud gaming, for instance, or collaboration, and the ability to quickly move the NF to the right places, right? So if you have people collaborating or congregating around a certain area, you move the compute functions in there to allow them to get the SLAs that they need to collaborate. So you see things like that, right? So you can also look at sort of time of day shifting, workloads across locations, time of day, depending on where things are concentrated, right? So maybe there's an event happening right near a stadium, and then you move your processing capabilities on there, or you use the cloud locations that are near there, to compute some, scoring or things like that, video surveillance. So certainly, we see some of those use cases as being dynamic use cases, right? To move your NFs as you see fit. So we're seeing a bunch of those, definitely. And the more dynamic, the more volatile, the more important for NF placement.
Those are great points. Yeah, and one of the things I think are going to be some eventual opportunities is the realm of real-time autonomous applications that we write about quite a bit. And there's a lot of different ways to think about that, right? Whether it's industrial context, what we call micro IoT scenarios like a smart factory. Because if you're hosting for intense critical environments like that, a private network, 5G network, can bring a lot of value.
Yes,
it can. Domain.
Absolutely.
Whether it's security, isolation, you mentioned isolation, being able to isolate different functions for a smart factory, and then being able to provide, if you have, whether it's an unlicensed or, licensed spectrum that you're using, being able to delegate that and then guarantee services across a wide range of requirements. Right.
Correct.
And then I think from the challenging stuff is going to be the more macro stuff, right? Like the macro IoT, autonomous vehicles that everyone talks about. That's where I think the densification of the network, being able to provide the ultra reliable quality of service is just going to be challenging, but that's a realm of opportunity. It's just a matter of economics and value. Actual value to the end user, whether it's a consumer or enterprise, right?
Yeah, because these things cost money. Orchestration is not cheap, not free. And so the question is there a business model behind that, right? So, and that's something that we'll also have to figure out, right?
Oh, yeah.
Someone's going to pay for this at some point in time.
Right. Well, this is the way I look at it, Roy. This is a wonderful way of taking the next step and figuring that out. I was talking about this big knowledge gap between the folks who do the technology and then the end users. It's a much bigger gap than I think a lot of folks recognize or would like to admit. It's very significant. And if we can start to bridge that gap, then we can enable folks across these different domains that need to talk to each other, start to really get to some practical and valuable innovations, right? Otherwise, we're just reading articles and then also the opining of other analysts and experts who are saying, well, the stuff is either going to save the world or, it's all a bunch of hype. Right.
That's correct. There is a lot of hype, and I think it does the whole industry a disservice, right? It's important to talk about the reality of what we have
Yep.
and to create, a common vocabulary and common ground, as you say, right? If the end users and the providers, of those services can have a common language to talk about and understand sort of where, sort of where the state of the art is, and then you can have a productive conversation, right? I think that's the goal.
I like
right?
that.
That's the goal. No, I completely agree with you on that.
Yeah. Well, Roy, thanks for joining me on this discussion. It was really, really good. I'm
very welcome.
Tremendously. And why don't you take a moment to let our audience know how to contact you, get access,
Sure.
Some of the great work that you do.
Well, thank you. Yeah. And we can be reached. Just find us on the web at AvidThink, AvidThink.com, and all the contact information is there. And you can find us on Twitter as well, likewise. And so if you are interested in some of the papers that we provide, find us on LinkedIn, find us on Twitter, just look for AvidThink, and you're pretty much across most of the social. Apart from Instagram, we're not really there, not Pinterest. We haven't found a good use case yet, but we're working on it.
No Facebook? Okay.
We have Facebook. We're not very. I'm not very. Let's just say I'm not very up to date on Facebook.
Okay.
But LinkedIn and Twitter, absolutely. We have YouTube videos too.
We're providing a link to his white paper on the abstract for this podcast. Check it out, and also check out our white paper, which is 5G Autonomous Edge. To our listeners, thanks for joining us. If you haven't already, please subscribe to our YouTube and Apple podcast channels, and visit us at www.next-curve.com. Okay, I got it right. That's always the hardest bit. And until next time, be safe and stay healthy. And Roy, once again, thank you so much. Great conversation.
It was our pleasure. Thank you.
Visit us at www.next-curve.com.